Welcome back to a new video. In this video, we are going to create a data science project. We are going to do data cleaning, data analysis, data visualization, feature engineering. We are going to train machine learning models, and we are going to create a web app using Streamlit. I'm going to be sharing the dataset that I'm going to be using in this video in the description. Let's start coding. So I'm in the Kaggle page of the dataset that we are going to be using in this video, and our dataset is about laptop prices. And let's see what's about. The dataset emulates laptop prices, capturing various features commonly associated with laptops and their corresponding simulated prices. The dataset encompasses key attributes such as brand, processor speed, RAM size, storage capacity, screen size, and weight. So let's take a look at the columns. We have laptop price.csv. In the detail side, we have brand, processor speed, RAM size, storage capacity, screen size, weight, price. And we are going to be trying to predict this price column with the features it has on here. Also, we are going to be analyzing these features, and we are going to be creating a web app using Streamlit for this model and for users to get predictions from it. And what I'm going to do is I'm going to leave this Kaggle link in the description of this video, and you can just visit that page if you are going to code with me in this video and download the dataset. In this way we can code together and we can train machine learning models and create a web app, and you can add this project to your portfolio. Okay, in Kaggle you can just use this download button to download the CSV file, and after the download and putting the file in the same destination where you are going to run this project, we are going to be ready. So I'm going to be recording in my code editor in a second. So I'm in my code editor right now. I'm going to create a notebook file like for the laptop price analysis.ipmb for the analysis, visualization, and modeling side. Also, I want to show you that I put my CSV file in here, which I downloaded from the Kaggle, and also I prepared the data.txt. For leaving this link in the description for you to download, I'm going to be 100% adding that in the description. And now in my Jupyter notebook, I'm going to select kernel 3.11.4, and next I'm going to start by importing the pandas, and then I'm going to say pandas read CSV, and I'm going to copy the data file name in here. Then I'm going to say laptop price.csv, and it's loading successfully. After seeing that, I'm going to save this to something like data, and from now on, if I call the data, I'm going to be reaching to the data frame that we just loaded. So in here, what I'm going to do is I'm going to call data.head for seeing the first 5 rows. Also, it is defaultly 5, but you can change this number. Like if you say 3, you are going to see the first 3, you say 1, you are going to see top 1, and you say 10, you are going to see the first 10 rows like that. Also, we have tail, which displays the last rows. So when you say tail 10, you see the last 10 rows. When you say tail like this, you see the last 5 rows, and you can specify the number like that. So let's go ahead and see the features we have. So in here we have brand, and we have different brands like Asus, Acer, Lenovo, Acer. Processor speed, we have this kind of values. Floats, RAM size, we have integers. Storage capacity, we have integers. Screen size, we have floats. Weight, we have floats. And at the price side, we have floats. Okay, so I'm going to call data.info, and let's see, we have 54.8 kilobytes memory usage, and we can see the data type counts and our range index. Also, I'm going to say data.shape. So we have 1000 rows with 7 columns we have. And next, what I'm going to do is in here, I want to see how many different brands we have. So I will say data, by the way, we can keep the shape in our notebook. Data, I will say brand, and I will use .unique function. So we are going to get the unique ones. We have Asus, Acer, Lenovo, HP, and Dell in our dataset. And if we call the number of unique, we are going to see we have 5 different laptop brands in our dataset. It looks great. So let's start to our analysis. Firstly, I want to start with data cleaning. So I'm going to check if we have any NA values and duplicated values. So at the NA side, we can say data is NA and it's going to return boolean cell-wise, like true and false. If a value is NA, then it is going to return true in here. And if we say sum after that, we are going to see if we have any NA values column-wise, but it's 0. Also, you can say sum again for getting the total NA value count. And if you had, like if we had in our data NA values, we can simply do data drop NA and we can set it like in place equals to true. Because if you don't specify this, or if you don't say like data equals to data drop NA, then you are going to have a new data frame displayed on the cell, but it's not going to modify the original data frame. So you can do like drop NA and in place equals to true if you have any NA values in your data set. So for the duplicated side, we can say data duplicated and we are going to get booleans, and we can call that sum in here and we are going to see the sum. We don't have any duplicates, and if we had, we can do data drop duplicates and we can say in place equals to true like this if we have any duplicated values. Great. So after that, what we can do is I'm going to call the data.head 2 again for seeing what we have in our data. So I'm curious about the statistics of this numeric columns. So I will say data describe and we are going to get the numeric column describes. So at the processor speed side, we have mean 2.75 and minimum 1.51 and a maximum 3.99. At the RAM size, we have mean of 15.5, minimum of 4, maximum of 32. And at the storage capacity size, by the way, it's really hard to work with a 4 GB RAM laptop. So storage capacity, we have the mean of 584, minimum 256 and maximum 1 TB. And screen size, we have mean is 14 inch, minimum is 11 inch, and it's maybe similar with most of the cell phones. So at the maximum size, we have 17 inch. By the way, I saw laptops which has 27 inch screen and it was like a television. So I prefer laptops in generally 14 to 16 inch is the best in my opinion for the laptops. And at the mean size, we have at the mean weight, we have 3.46, minimum is 2 and maximum is 4.99. And I think most important for the video, we have the mean price of 19,000, minimum price of 8,500 and a maximum of 33,500. Okay, so here is our numerical statistics for the numerical columns. So now I want to check the correlations we have. So I will say data frame, select data types, and I will say include numbers like this, and we are going to have the columns, the numeric ones, and I'm going to set it to something like numeric data, and it's going to be this. And now I will say numeric data dot correlation, and here we have the correlation matrix. By the way, the 1 means strong positive correlation and -1 means strong negative correlation, which means that in strong positive correlation 1, the numbers move together. Like if think like we have x and y and they are correlated as 1. So if x goes up, y is going to go up, and if x goes down, y is going to go down. And at the -1 side, strong negative relationship, if x goes down, y is going to go up, and if x goes up, y is going to go down. So they are moving differently in the strong negative correlation, and they are moving together at the strong positive correlation. So at the price correlation side, we can see that price is highly correlated with storage capacity, which means that the increase in storage capacity increases price. Also, we can see that it's negatively correlated with the screen size and processor speed, and it's positively correlated with RAM size, as it can be expected, and it's positively correlated with weight, so it's unexpected. So this one, and this one is unexpected, because if the processor speed goes up, we expect price to go up too, and if the screen size increases, we expect price to increase too, but it doesn't matter. So we can continue. I'm going to call the data.head again for checking what we can do. Now we can group our data by different brands and see the features we have. Like, let's group our data by brand, like this, brand, and let's check the prices we have averagely, like this. So we have, let's sort it by descending order. You can sort it. By the way, this group by, I'm going to cut it from here. This group by returns a panda series, which means you can manipulate it in the way that you want. Like, you can use head, anything. You can say head, or you can say, let's say minimum, and you can say index minimum, like this. You can say index maximum, anything that you want. Like, you can manipulate it in the way that you want, and we are going to do that right now. I'm going to sort it in the descending order, and we can see that Acer has the highest price, and from this what we can do is we can create a plot. So I will say that plot, and I'm going to set the kind as bar, like this, and we are going to get a bar plot, but we needylabel, title, etc. For that, I'm going to import matplotlib, and then I will say I'm going to give it a title like plt.title, and I will say like average prices by brands. I'm going to give it a ylabel, like, let's say average, and I will use plt.show at the end for making this disappear. And now we have a better looking plot. Great. By the way, if you change the order in here or do any manipulation, you can get the plot changed in this way. Like, I'm going to set it to true. Now I will say false. It's going to change again. And after this, if I want to plot the top 3 or top 2, I can say head 2, and we can see that we have different things in this side. Also, we can do like pie. We can create pie chart in this way, and we can manipulate this in the way that we want. Okay, great. I'm going to call data head again, and let's see what we can do else. Okay, I want to see the RAM sizes by brands. So I want to see, like, at the 4 GB RAMs, what is the count of the brands that is producing that type of stuff. So for that, I'm going to say data frame group by, and I will say RAM size. I'm going to group by this RAM size this time, and then I'm going to say, by the way, I made a typo there. I need uppercase letters like this, group by RAM size like this. Then I'm going to say by brand, and I will use value counts like that. And here is our information. So we have RAM size, brand, and at the 33 GB RAM size side, the leader is Dell, and they are all sorted in the descending order by RAM sizes, like Dell. Okay, so we can say reset index if you want this information as the pandas data frame. Also, what we can do is we can call data brand, and we can use value counts like that. So we are going to have this. Okay, let's say sort values ascending false, and plot kind pie. So we can see the laptop brand distribution. I will say title like brand distribution of data and I don't want y label in my pie chart, so it's going to be empty, and I will use plt.show. So here is my pie chart. So it seems like Asus and Dell, it seems like equally distributed, like I can't even remember. I'm going to take it and check. Yeah, they are pretty similar, but Dell is the winner, Asus follows, and Acer is the third. Okay, so we can continue with the modeling side, and for that, firstly, we need to select our X features and Y feature. So Y is surely is going to be regression problem, data, price, and at the X side, what we can do is I want to include on my predictive model, I want to include storage capacity for sure, and actually we can include most of them. I will call data.columns, and I'm going to pick from there. I'm going to take processor speed, RAM size, storage capacity. I'm not going to include the screen size, and let me change this quickly like this. I'm not going to include screen size and weight. I want it to be simple, so I will have 3 features, and whenever I call the X, we are going to have this kind of values. So as the next step, I'm not going to do scaling because I'm planning to train a random forest regression model which doesn't require any kind of scaling because tree-based models are not affected from the range of the X values. So as the next step, we are going to split our data into training and testing set, which means if you set, let's say that you have 1000 data points and you set the test size as 0.2, then it means that 20% of your data is going to be in your testing set and the 80% is going to be on the training set. So you are going to train your model with that 80%, in our case 800 data points, and you are going to test the model's performance with the 200 data points you left when you are doing training and testing split. So for that, we will say from Scikit-Learn that model selection import train test split, and then we are going to set X train, X test, Y train with Y test as train test split, X, Y, and test size as 0.2. So we are going to have same length on the X train and Y train because it's going to be our training data. We are going to train our data with X train and Y train, and we are going to test it with X test with Y test, so they have the same size. Great. And now what we can do is I'm going to say from Scikit-Learn dot ensemble import random forest regressor like this, and I'm going to initialize the model like IFR model, random forest regression model, and it's going to be random forest regressor like this. Also, I'm going to initialize it like that, and I'm not going to train a base model. I'm going to use grid search for parameter tuning, which means that in machine learning models we have a lot of parameters, but we can tune them, which means that find the optimized parameters for getting the best performance. So for that, I will say model selection import grid search cross validation, and I'm going to do like create a parameter dictionary for the random forest model. Like I will say parameter grid RFR and grid random forest regressor. We will say there can be max depth, and I'm not going to give a huge list, but I will give like 2, 5, 10, 15, 20, and 25. Then I will say maximum features, and on that side I will say auto and this, and next I will say number of estimators, and I will give a list like 2, 4, 6, 8, 10, 12. This is going to be my parameter dictionary. And now what I'm going to do is like I can do like this, and now what I'm going to do is I'm going to initialize the grid search. Like I will say grid RFR is going to be grid search cross validation, and I will give RFR model dot, not dot, separate parameter grid RFR. I will give them together, and then I will say grid RFR that fit, I will give my training data like this. And there's a typo, I need lowercase t, and now I'm training my model, and now we have our model ready. So what I'm going to do is I will say grid rfr.best parameters. So max depth 25, number of the estimators 12, and maximum features this selected for the training side. So if you want to increase the model performance, you can just extend this list in this order, like we have 12 in here. So we can simply go increase this number in this way, like we can add 14, 20, 30, and you can do some optimizations like that. I'm not going to do that because I don't want to spend too much time on the modeling side. So next, what I will do is I will say grid rfr.predict, and I'm going to make predictions on the X test, and now I'm going to store them on predictions in the side, and I'm going to compare these predictions with Y test for seeing how suitable they are. So I will say from Scikit-Learn.metrics import mean absolute error, and I will call mean absolute error with Y test with predictions. So it's 380. So you can evaluate this performance on the target column you have, like we have the data, it was price, and I will say describe, and we can see that mean is 19,000, but we have the standard deviation of 9,000. I think this is a really good score, by the way, but it depends on your case and the thing that you want to achieve, but it seems pretty good to me, and we are getting a good estimation from our model. Now we are going to create our web app for getting predictions from this model with the entered features in our dataset. So I will say X. So when we create the web app, any user, like you can deploy this app, any user can come and enter these features like processor speed, RAM size, and storage capacity, and get its price prediction. Like it can be useful for people who sell laptops and want to give a price estimation for a laptop, or who buys it. Actually, it will be more helpful like for the second-hand laptop size. And if you are going to buy a laptop, you can compare its performance with this kind of models, and we have countless way of using this kind of machine learning models in our real life. So they are useful, and I'm going to get this x.columns list. I'm going to copy that because I am going to use that. We are going to take the inputs in this order when we are giving the model the inputs. Like we need to give the model the prediction estimators in this order. So we have our model right now in here. Now it's time for exporting it from Jupyter Notebook, since we are going to use it in our app. So I will say import joblib, and I will do joblib the dump, and I will say grid rfr, and let's dump it like, actually grid rfr like random first model, and it's going to be a pico file. So we are going to see that in here. So I'm going to summarize what we did in the notebook, and we can go to the web app creation. We loaded our data set, we checked if we have any NA values or not. Then we checked for the summary statistics, and we checked for the correlations. Then we created some plots, we did group bys, we've selected our features in here. Then we applied train test split, and we trained our model. Now we exported it. So I'm going to copy this column names, and I'm going to save this notebook. As the next step, I'm going to create a Python file like app.py, and at the first place I want to just write this as common because I don't want to forget that. And now I will say import Streamlit as st, then import joblib, and also I'm going to import the numpy. I can import it in here, import numpy as mp, and I will say like at the first place I'm going to load my model, like model is going to be joblib.load, and I will just take the name from here, random first model.pickle. Now when we load this model with its methods, we can get predictions from this model. So then what I'm going to do is I'm going to create a title like laptop price prediction app, and I will say Streamlit.divider. I use it a lot when I'm writing Streamlit code. I think it makes app look really good, and we can write a text like, with this app, after using the calculation button, when you entered the values of processor speed, RAM size, and storage capacity, you can get a price estimation for your laptop, for the laptop you want. So in here I'm going to just delete the underscore, and after this we can use divider like this, and now we are going to take our inputs from user. Like for the processor speed side, like processor speed is going to be Streamlit dot number, actually we will say st number input, and the label is going to be enter processor speed. And let me check its values, like what's looking like. I'm going to find, yeah, here I call the x, so it's between, like it's a float, and we can say like value is going to be, let's say 2.5. so we can specify it's a float like this, and let's set the step as 0.5. okay, and next what I'm going to do is let's do like this, and let's do like this, because maybe it can be entered like 3.89 instead of 3.9, and 2 decimals in that way. And for the RAM size, I will say Streamlit number input and enter RAM size. Let's set the value defaultly to 16 and step as 4, because 4, 8, etc. It can go like that. And next what I'm going to do is, actually let's set it to 8, the step size. And next I'm going to say storage capacity, and it's going to be Streamlit dot number input enter storage capacity, and I will set the value as, let's say the storage capacity defaultly is going to be 512, and step is going to be, let's say 256. okay, so these are going to be our inputs, and in here we are going to store them in something like x, like processor speed in the same order, RAM size, and storage capacity. And we don't need this anymore, we can delete it. And now what I'm going to do is I'm going to say Streamlit.divider, and I'm going to define a button like prediction is going to be Streamlit.button, and click the button for getting the laptop, let's say like price estimation, shorter better. So I will say if, after divider, if prediction button applied, do this. I will firstly write the else. I will say Streamlit.write, please use the button for getting a prediction. And in prediction side, what I'm going to do is I will set something like x1, and it's going to be numpy array, and I will say x. Then I'm going to say prediction is going to be model.predict, and I will give x1 like this. We need to give a two-dimensional array, so why I'm using brackets in here is this. And then we can set like Streamlit.write price estimation for the laptop is, and we can say, we can use an f string in here, and also we can use the first element from this prediction. We can say prediction, and for making it look prettier we can say 2-point float like this. And I think it's great and let's test it out if it's working. I'm going to say, after writing this code, actually let's add an animation for the button. I will say streamlit.balance like this, and when the button applies, it's going to be showing balloons. And now I'm going to come to terminal and I will say streamlit run app.py, and when I apply that, it automatically opens a web page on my browser. If it's not opening a page in your browser, you can just go to your address from any browser that you want. I'm going to be using Safari. You can use Google Chrome, Opera, anything that you want, Firefox. Just copy this address and go to there, and I'm going to be re-recording on that page. So in here I have my laptop price prediction app. With this app, after using the calculation button, when you enter the values of processor speed, RAM size and storage capacity, you can get a price estimation for the laptop you want. Okay, let's try it. It says please use the button for getting a price prediction. I used it and it says invalid format specifier. So there's a problem at the string formatting at the end. So let's fix it together quickly. I think in here I just mixed up the places. Like now it's going to work out smoothly. It was the change we need, and I saved my change. As you can see at the top right side, it says source file changed. I will say refresh and I will use price estimation button again, and okay, it works with our formatting and we can get a prediction from it. Like let's do 1024 8 and let's say 3.5, and let's get our estimation. Great. So here is our app, and let's decrease it like 256, and also the price decreases. So our app is working smoothly and we have our model in web app right now. So I'm going to go to the VS Code again, summarize the Streamlit code, and that was all for the video. Our model is working smoothly. So I will say like let's enter RAM size 32, 1024, and we get this price estimation. Amazing. Okay, let's go to the VS Code again. So I'm going to close this terminal and I'm going to talk about this code. In here we import Streamlit numpy joblib, we load our model with its methods, we create a title, we use divider, we add a description, we use divider. In here we take user inputs, like we can specify if it's going to be float or integer by specifying this kind of values, value, minimum value, maximum value, step. Then we save it like X. We add a prediction button, and if that button applies, we run this code, else we run this. And in here we create an array and we make it two-dimensional, and then we pass it to our model and get the prediction inside of it. Then we write price estimation for the laptop is, and we use an F string with its formatting. So that was all for the coding part of this video. Thanks for watching this data science project. I'm sharing new data science videos every week on my channel. You can subscribe for more. I have a playlist of data science projects where I have more than 30 data science projects. You can visit that playlist from the cards of this video for more videos like this. Have a great day.